This is our last video to get you ready for the quiz over exponents and radicals. And this video is going to go through a couple solving problems, which is what we're starting with, and then a few simplifying, focusing a little bit more on the radical ones rather than the rational exponent ones. So first thing you have here is two equations you're asked to solve and then route any answer or answers that you get to two decimal places. So the first thing we want to do is we want to isolate the piece that has the power to it. So I need to move the minus 3 first, so I'm going to add 3 to both sides. So that's going to give me 2, and then the quantity x plus 1 cubed equals 8. Then I want to divide everything by 2. Remember, you can't distribute that 2 through because that x plus 1 is being taken to a power. So now I have x plus 1 to the third power equals 4. Now to get rid of a cube, the opposite inverse of a cube is cube root, so I'm going to take the cube root of both sides. Because it is an odd root, you will only get one answer, whatever the cube root of 4 is. So here's where I'll need a calculator. Cube root, couple ways to do it. You could go to your math menu and you could type in number 4 and you could do the cube root of 4 that way. The other option is we talked about how the cube root is the same as the 1/3 power, so you could also do 4 to the 1/3 power. Does not matter to me which way you do it. Either way, you'll get the same answer, 1.587. And then my last step is to subtract 1 from both sides, so x is approximately 0.587. Second one, we want to get the fourth power piece by itself, so we're going to add 3 to both sides. So we get 3x plus 5 to the fourth power equals 52. We need to get rid of the fourth power, so we're going to take each side to the fourth root, or the 1/4 power. So we have 3x plus 5, and now again I'm going to need my calculator. Fourth root, couple ways to do it. I think the easiest way is to just use the 1/4 power. So you're going to type 52 caret and then 1/4 power. The other option is if you want to use the fourth root button, you actually have to type in a 4 first and then go to math and choose the fifth one there, which creates the same thing. You get the same answer either way. Now, one thing to notice on this one, you are taking an even root. When you take both sides to an even root, you get plus or minus that answer. So we have 2.685. We want to write plus or minus 2.685. 685. Now, since I'm not done, since that's not my final answer, I'm actually going to create two branches and say that either 3x plus 5 is equal to the positive 2.685 or 3x plus 5 is equal to the negative 2.685. We'll do the positive first, so we're going to subtract 5 from both sides. Here's where it's nice to have it on your calculator, so we're going to take that minus 5. And then we're going to take that answer divided by 3. So we're going to get 3x is equal to approximately negative 2.315. And then divide both sides by 3. And again, since it's already on your calculator, we can just hit divided by 3. And we get an answer of approximately 0.771 or 0.772 negative. On the other side, we're going to subtract 5 from both sides. So now we've got negative 2.685 minus 5 to get negative 7.685, and then we're going to divide both sides by 3. So we have 3x is approximately negative 7.685. Divide both sides by 3, and again, having a calculator does make it easy to just hit divided by 3. And so my other answer is approximately negative 2.561 or 562. So here are my two answers. A little more work when you're taking an even power because you get plus or minus when you take that even root. And if you're not done at that point, then you do have to consider what would happen if you had the positive and what would happen if you have the negative. If that's your last step, is taking that even root, then you can just write plus or minus the answer and move on. The second thing that I want to go through is just some basic simplifying when it comes to radicals. So we're going to start with the first one, which has a big thing under the fourth root. Remember, what you're looking for is perfect fourths, things that are to the fourth power. So if you think about perfect fourths, the first one that you should know is that 2 to the fourth is 16. So I'm going to make a factor tree. 80 is divided by 16. It is divisible by 16. You get 16 times 5. The x to the fifth, I'm going to make a little tree and say, well, that's actually x to the fourth and then an x, because I want my powers to be multiples of 4. y to the 8th is perfect because 8 is already can be divided by 4. And z to the 3rd, it will never change because it's not big enough. Doesn't even have the 4th power. So what we do is we take each piece out. If it is perfect, we take it out. It kind of gets out of the 4th root jail. If it is not perfect, it stays underneath the radical. So the 4th root of 16 is 2. It comes out. The 5 is stuck under the radical. Sorry, I wrote the wrong power there. So that should be a 4th root. So 5 is underneath. Then I'd have x to the 4th power to the 4th root. Remember, we divide power by root. So 4 divided by 4 is 1. So we have x to the 1st that comes out. And then we have this extra x that's stuck underneath. Then we go through the y. 8 divided by 4. Power divided by root is 2. So you get a y squared that comes out. There are no y's left underneath. And then z to the 3rd will forever be stuck under my 4th root. And this is your final answer. You do not have to write the 1 as the power of x. You can just write 2x, y squared, then the 4th root of 5x, z cubed. Next one, when we want to add roots, we need to make sure they're like roots, meaning they have the exact same number under the radical. So I'm going to make factor trees here. We're looking for perfect square factors. So 18, the perfect square factor is 9, so it's 9 times 2. 50, the perfect square factor is 25, so it's 25 times 2. We take the square root that is the one that is perfect. It comes out. It gets multiplied by what is already there. So when I take the square root of 9, I get 3, but it's times the 3 that was already there. So 3 times 3 is 9. And then you still have a 2 stuck under the radical. Take the square root of 25. I get 5 times the 6 that's already there. So 5 times 6 is 30. And then the 2 is stuck underneath. And now they are like radicals, so we can add 90 square roots of 2 plus 30 more square roots of 2 gives us 39 square root of 2. And the last one you're going to have to FOIL. So we're going to go through all 4 pieces of FOIL, and then we're going to see if anything can combine or simplify when we're done. So first thing I'm going to do for FOIL is multiply the first. So I can multiply this 3 times this 5. I get 15, and I still have a radical 5. Then I'm going to do the outer. When I do the outer, I can multiply the 3 times the 6. That's going to give me 18. And then I'm going to multiply square root of 5 times square root of 5, which ends up just being 5. Now I'm going to do the inner. Negative 2 times 5 is negative 10. And then I'm going to do the last. Negative 2 times negative 6 is positive 12, and it still has a square root of 5. A couple things that I can do is I can multiply this together. I can figure out what 18 times 5 is. And again, if you need a calculator, just come over and type 18 times 5. So I get 90. So I'll have 15 radical 5 minus 90 minus 10 plus 12 radical 5. I'm going to add the like pieces together, so those two can be added, and those two can be added. So my final answer, I have negative 100 when I add negative 90 and negative 10, and I have 27 radical 5 when I add my like radicals together. So this, combined with the other 2 videos that review exponent and exponent simplifying, should make sure that you are set to take a quiz over everything we've talked about with exponents, radical notation, and rational exponent notation.